Also alles bis auf die Detektion zu Welle, Kamera, einfach Qualität oder sowas und AI-Traffic jetzt. Und wenn ich dann AI-Traffic ich will gar nicht mal diesen Anfragen kümmern. Rausstehen die Leute, unsere Verkäufer, die mit Counting-Line-Korridor und mit Crowd-Estimates und sowas versuchen.
So, man kann ja nichts erkennen.
Ich habe aber keine Ahnung, von wie das eigentlich funktioniert. Ich gehe ihm sofort ab, ich kann ihm weiterhelfen.
Du kannst sogar die VR. Wir können
wollen wir weitermachen.
up to 12 hours
Also irgendwie
jump within the stream. 12 Stunden.
Was? Du warst beim CAH dabei, wo ich sagen, wann kriege ich dann diese verdammte 111er zum öffentlichen Download? Da habe ich gesagt, ja, die dürfen doch gar nicht mit raus. Ich habe die Woche schon wieder Freischick gehabt mit irgendeiner der 109er.
Du kannst sogar noch
Die Dinger sind falsch ausgeliefert, weil irgendwo ist Werk.
ein Link des
Alle und sind es Das ist nicht richtig.
kann nicht funktionieren, weil ich eben erst gestreamt habe.
Ich weiß nicht, wie es passiert ist.
That was 1 minute.
Was ist denn mit so drauf?
Genial.
Gutes Weekend-Projekt. Diese Windows. Da sind wir jetzt genau bei dem, was da ist.
Das jemand gemacht hat, also ein YouTube-Video.
Genau das, was wir dabei mit diesen losen Steckerdämmen. Die Entwicklung sagt mir, ja, Moment, wenn die 111
Du musst Windows 10
gar nicht Lauter wollen, das ist das, was mich erzählt. Das ist vom Plan her viel als die wird alles gut. Der Punkt ist aber, dass es ständig zu jedem Thema intensiv wird.
Good grammar and spelling are important, but if you want to write essays that inspire, messages.
Hello, my name is Gary. Different equipment credits here for them because they've done an absolutely amazing work together. Can be quite tricky. Now I had to try this several times. A53 running at maybe 1.4 gigahertz. Even a reasonable mid-range smartphone will have an octa-core processor with some of the high-end cores being Cortex A73 or Cortex A for running Windows 10 on ARM because it really is painfully slow onto this device. Preview technical means. So they're all the negatives, but what about the positives? There are some very positive sides about this. First of all, is Gary explained that some very clever people have taken Windows 10 built for ARM and they've taken the Raspberry Pi and they've made the glue in the middle that can make the two work together that brings you a full Windows 10 desktop on a Raspberry Pi. Now I've spent a few days playing with it, trying to get it to work, and I'd like to share with you my experiences of what I have found out. So if you want to find out more, please let me explain. Now, as I've said many times on this channel, ARM-based processors are not just for smartphones. We find them in a whole range of different equipment, including now in servers, and I highly recommend you go and look at my Amazon Graviton video, because that shows how you can run AWS instances on an ARM-based processor on Amazon's cloud services. And of course, another popular place where we find ARM processors is in the Raspberry Pi. Now, the Raspberry Pi has a quad-core Cortex A53 processor and 1 GB of memory. Also, Windows is no longer just for x86.
Warum
Ja, darum.
Wollen alle nur Windows 10. Ja, ich würde auch erst mit Linux probieren. Nur ein Zehntel CPU lassen. Maximal halb so viel wie Windows. Also besser ist es definitiv. Oder? War das bei den Dingern? Kannst du da noch mehr RAM machen? Nee,
Wenn die 4 hat, 4 Gigabyte.
was kostet der auch?
Genau so 40 Gehäuse.
Ich mache es erstmal mit 3. Solange ich den habe. Autokriegkarte. Mir gekauft. Hier für Chipset. 2 Euro bei aber die hat das ist ja, der auf der Google ist ja 2 Millionen.
Das hatte man dabei schon.
Eher auf Pause. Pause. So, jetzt geht es zurück.
Ja, jemand hat sich mit
Aber du siehst
groß ein Paket gebaut.
Genau. Deswegen spiele ich habe ein Bildschirm zu Hause. Spiegel machen.
Ja, aber jetzt muss er die Ansicht aufmachen, um zu sehen, ich bin auf Pause.
Smartspiegel?
Deswegen.
Ach ja, das habe ich auch gesehen. Das muss geil sein.
Licht an oder Licht aus. Fertig. Also
Ja.
visuell offensichtlich. Nee, aber ich denke, das ist der hatte mal vor 3 Wochen am Reden. Das ist einer da. Siehst du auf Pause, sehe ich, dass die hier beschäftigt sind. Ich sehe, du bist immer noch angemeldet.
Die müssen richtig geil
Benny
sein.
ist auf Pause. Ich bin
Ich
angemeldet.
bin an die Wand, keiner weiß.
Ich bin angemeldet. So.
Aber es ist ein bisschen Arbeit.
Check out this Miners lamp. It's got history, it's got character, it's hand what I was using to do forever on my own, but that's okay, that's what Helpful Sisters are for. As a team, we really got stuck in and gave it some serious elbow grease, and it looks loads better already. Still, there are plenty of scratches, so we're going to move to using wet and dry sandpaper of finer and finer grit values. This makes the surface gradually smoother and smoother, and eventually the hope is to reach a mirror shine. But it's going to take a while, so I'm going to leave Al to it whilst I work on the side panels. For these I'm using some thin plywood, cutting out various holes and slots with a jigsaw. Now these being plywood, they aesthetically don't look great, but that's okay because I'm going to be covering it with something else to give it a better.
Hey guys, I'm Davis.
And I'm Aaron.
And in this video we're going to be making a one-way smart mirror. It's basically a mirror with a monitor right behind it, and the mirror is reflective.
So let's get started.
So to see how this is all going to come together, we built a 3D model of it on the computer. And first we started out with this mirror that we bought here, and we're just going to build a frame around it using 4 pieces of wood. And we're going to put that mirror right on the back of that frame. And then for the sides of the frame, screw right into the frame there, and then these triangular.
And these are going to be corner cuts and glued together using 2 additional pieces at around 23 3/4 inches. angle. And this piece is going to be about 25. Put this on the inside of the frame here and sandwich it in between the frame and the monitor. So one thing we learned when we were doing this is that this stuff is pretty brittle here. So if you're using some thick shears like this with wide blades, that's going to crack the sides a lot. So we had to switch to some thinner scissors. And you also have to make sure it's pretty sharp too, otherwise that'll also make it more likely to break. One thing we learned that helped is that if you're going to cut it, if you put some tape on there and cut along the edge of the tape like this, then this side may crack a little bit, but when you lift the tape up, it's smooth underneath and you get a straight edge. So, still to get a low profile monitor. This monitor is just over 1/2 inch thick, so it sits in the frame really nicely. And if we flip it around to the other side, it just looks like a plain old mirror.
Warum kein Smart Home?
Smart Home? Totaler Quatsch.
I'm connected to my Raspberry Pi again through VNC. We have a repository online for Smart Mirror. First thing I'm going to want to do is download this repository. So I can open up my terminal and type git clone this repository. So the next thing I want to do is install all the dependencies for this project. So you want to make sure that you have pip installed. If you don't have it installed, you can just Google how to install pip. So I need to run pip install -r requirements.txt, and it will install all of my requirements. And you might have to run sudo pip install -r requirements. Okay, now all of my dependencies are installed. I need to change a few things in my smartmirror.py file, so I'm going to open that with vim. So if I type vim smartmirror.py, it will open up my file. And so we have 3 variables set here. One is IP, one is country code, and the third is weather API token. You need to set your IP of your Raspberry Pi to this variable, and it's used for location. So we have a service that gets the location of your IP, and from the location we determine what the weather is, the forecast for the next few days. So if you go to ipchicken.com, it will give you your current IP address. And then the country code is used for news. So it's a ISO country code. Since we are in the US, we put US here, but you can use your own country's country code. And then the weather API token is from a site called forecast.io. So you'll need to make an account on forecast.io. It's free, and it will give you an API token, and then you would just replace it in here. This is the forecast.io site, and if I scroll all the way down to the bottom, there will be a forecast API under developers, and if you register, create an account, it will display a API token, which is just a string value. And so once you get that, you can come back to your smartmirror.py and then replace this token here with your API token. Once I've done that, I can just hit escape and then capital ZZ to save. Okay, now I can go back to my console, and I'll need to do one more thing before I start this. I need to install one more thing, and that is Python imaging TK. So you can install that with sudo apt-get install python-imaging.tk. And after I run this, I can run python smartmirror.py. And depending on how slow your network connection is, it might take a few seconds to start up. Okay, so now it's loaded, and if I click on the window and press enter, it goes full screen, and then if I press escape, it returns to just the window view. So let's hook our Raspberry Pi up to the mirror and set it up so that it runs this application. So now I have my Raspberry Pi hooked up to my smart mirror, and the display is still in landscape orientation, and I need to switch it to portrait. So in the /boot folder, there should be a file called config.txt. If you use sudo vim to open up this config.txt file, you should be able to scroll down to the bottom, and we need to add a variable. So I added this variable called display_rotate, and I set it equal to 1, and this will rotate the monitor so that it is in portrait orientation. So if I press escape and then :WQ exclamation mark, it will save this file. And now I need to restart my Raspberry Pi. Okay, so now we are in portrait orientation. I'm just going to run the application. Now I'll hit enter to make it full screen. And now we have our very own smart mirror set up.
Alright, so that's it for this video. We really hope you liked it. Eventually, we actually want to incorporate some AI components into this mirror where you can talk to the mirror and the mirror will talk back to you. But unfortunately, that was just a little too much for this video. So if you want to stay up to date with all our other videos, make sure you subscribe if you haven't already. But until then, see you next time.
Hi everyone, in this video I'm going to show how to set up a web server with a Raspberry Pi. I happen to be using an older Raspberry Pi, but that's just because I have a bunch of full-size SD cards laying around. But it's exactly the same for the newer Raspberry Pi 3 or the 2 or any other version really. In this video I'm going to cover how to set up obviously Linux, Apache, MySQL, PHP. We're going to use SSH to get access to the Raspberry Pi. I'm also going to show how to set up your own domain name, like your own .com, and how to connect that to your Raspberry Pi. And also how to use a dynamic DNS service, which will let you use your Raspberry Pi on a typical residential internet connection where you don't have a static IP. I did a similar video before, but I didn't cover the domain name part or the dynamic DNS part, so that's why I'm making this video again. Anyway, so gather all your stuff. You're going to need a Raspberry Pi, a SD or micro SD card, micro USB cable, and a Ethernet cable. We'll start by taking the SD card or micro SD to your normal computer, not the Raspberry Pi, but your desktop or laptop, and we'll set up the card. Okay, so back at the computer, I'm going to go ahead and connect or plug in my SD card. And Windows detected it. So try letter E. Okay, so if you bring up a web browser, search for Raspberry Pi downloads. And click the first link. We want Raspbian. And we want the minimal image. Alright, so it's almost done downloading. In case you're wondering why I went with the minimal image instead of the full desktop image, because I'm going to use the Raspberry Pi only as a web server, we really don't need a graphical user interface, and it'll just be more programs that need to be updated, and could slow things down a little bit. So that's why I went with minimal. You can do it with the full desktop version if you want. That'll work just fine as well. Alright, the file finished downloading. We'll go ahead and open it. And it looks like that would be disk image. Okay, so we want to copy that and save it here. So basically that was a zip file. We're extracting the zip file. I'm putting it in my downloads folder. You can put it wherever you want. Okay, so we have Raspbian ready to go. We need to find a way to put it on the SD card. So if you go to Installation Guide, go down to Windows, click on the SourceForge link, and then click on the download link. Open the file, accept, create a desktop icon, and go ahead and launch it. So I've noticed that this happens sometimes. You'll get an error and it'll say that the requested operation requires elevation. What that means is that you need to run it as administrator. So if we go to the desktop icon, right click it, run as administrator, and then the error goes away. So you need to tell it where your image is. So you click on the folder icon, and I saved mine in my downloads folder, but wherever you put it, find it. And then you need to tell it the drive letter of your SD card. And if you go to File Explorer, this PC, on mine it happens to be drive letter E. On yours, obviously, it'll be different, or it could be different. So I'll pick drive letter E, and then click right, and confirm. And I'm using a very old, very slow SD card, so this will take a while. Alright, so it finished writing to the SD card. Click OK, click exit, and we can go ahead and eject the card. And now we'll go ahead and take the card back to the Raspberry Pi. So we got the card that's all set up. Go ahead and plug it in. Plug in your Ethernet cable. The other end is already plugged into the back of my router. And plug in your micro SD cable for power. Should see the lights come on. And now we'll go back to the PC and configure everything through the network, so we don't have to plug in a monitor or a keyboard or a mouse. Okay, so back at our regular computer, what we need to do now is we need to figure. What happened there? There we go. Okay, we need to figure out the IP address of the Raspberry Pi. An IP address is like a telephone number for a computer. And the way you can figure that out is by logging into your router. Typically that'll be 192.168.1.1. Okay, so I've logged into my router. Yours is probably going to be different because the interface will be different for different brands, different model numbers. That's the model number I have. So you might need to do some research to figure out how to make it work with your particular router. But on mine, if we go to Clients, and we go to Wired, we have 192.168.221. The reason why it has that host name is because I've actually used this Raspberry Pi before, and it knows by the MAC address the old host name, but it'll probably say Raspberry Pi. So on my particular network, with my particular Raspberry Pi, it defaulted to 192.168.1.221. Again, it'll most likely be different on your network, and if you don't have this particular brand of router, what you can do is figure out the model number of your router and search for that model number, and then how to set a static IP. So on mine, if you click the computer icon next to the device, you can click a padlock icon, and that will lock that IP address to this device. And you click OK. Alright, and so then the router will reload its page, but we're all done with that for now. Now we need a way to talk to that Raspberry Pi, and Secure Shell SSH is the way to do that. It's an encrypted command line interface to a Linux computer. And the program I use in Windows to do that is called Terraterm. So T-E-R-A-T-E-R-M. And click on the first link and click on download. And we want the newest version, which is 4.90. We want the exe. And there it is downloading. Go ahead and open the file. I guess I didn't open the file. Alright, go to downloads, open the file. Alright, so accept. All the defaults should be fine. Yeah, that's fine. Pick whatever language you want. And we'll go ahead and launch Terraterm. Okay, so when it opens up, you'll see what looks like a DOS window behind it, and then a little pop-up window that'll let you tell it what you want to do. So make sure SSH, Secure Shell, is selected. The default port number of 22 is fine. All these are fine. The host will be that IP address. I think it was 221. Oh, that's why it didn't pop up earlier. Okay. What was the IP address? Yeah, so again, on yours it'll probably be different, but on mine it's 192.168.1.221. So you type in whatever your IP address is, type it in here, click OK. And it'll say, well, okay, the first time you connect, it will bring up this confirmation and click continue. And then it'll say authorization or authentication required. The username by default is Pi, P-I, all lowercase. And the password by default is Raspberry, all lowercase. And click OK. And there we go. So this is basically a view into the Raspberry Pi. This window is your Raspberry Pi. We're logged in, username is Pi, the device name is Raspberry Pi. And what we can do now is we want to run the Raspberry config program as the administrator. So sudo sudo is superuserdo, which means run it as an administrator. And then raspberry-config is the name of the program. Press enter. Alright, so the first option, expand file system, we want to do that. That'll make it so that your partition will take up your entire SD card, which is what you want. So press enter. And it'll tell you that it has resized and that it will go into effect after the next reboot. So, okay. Change user password. You probably want to do that. So press enter. You'll be asked for a new password. Press enter. So enter your new Unix password. Obviously you want to pick something that's kind of a secret, but for this demo I'm just going to pick a password of password. So don't do that, but password for now. Press enter. Type in your password again. And it will tell you that it has changed it. Go down to boot options, and we want B1 console. Basically, the other ones would be for a typical like desktop computer, but for a server you really don't need any of that stuff running in the background, so B1 is fine. Press enter. Internationalization options. We can change the locale. And we'll scroll down. By default, it'll have ENGB, which is the version of English used in Great Britain. And I happen to be in the US, so I'm going to switch it to ENUS. So the star indicates that it has been selected, and you can unselect it by pressing space. And we'll go down to ENUS, UTF-8, and press space. And then tab, and that'll bring it, or that'll move you over to OK. Press enter, and pick ENUS UTF-8. Press enter. All right, go back again to internationalization options. Pick your time zone. And I happen to be in California, so I'm going to go to US. Let's see. I think it was Pacific, but I don't remember. Let me go back. Oh, okay. Go to America, not US. Go to America. And then I'm going to go down to Los Angeles. All right. Everything else is fine. We don't need to change anything else. So if you use the right arrow, you can go to finish. And it will say, would you like to reboot? And yes, we do, because we want that expanded file system to go into effect. So press enter. And in a second, TerraTerm will close. That's what happens if it loses a connection. So if you ever are doing something and all of a sudden the window closes, you lost your network connection. Anyway, so I'm going to go ahead and wait a couple minutes for it to finish starting back up, and then we'll open TerraTerm and connect again. Go ahead and open up TerraTerm again. And again, make sure you use your IP address for the Raspberry Pi. And username is going to be Pi. Password will now be whatever you set earlier. So again, I used password, which is a bad choice, but it's only for this demo. And then click OK. And again, we have our connection to the Raspberry Pi. So what we want to do now is download all the updates so that we have a reasonably secure system. Sudo apt-get update. So again, sudo is super user do, which means run this as an administrator. Apt-get is the tool that will let you interface with the package manager. It's kind of like the App Store, if you want, for Linux, kind of. And then update tells it to get a list of all the updates. So press enter. Okay, and now we can go ahead and install all of the updates that it might have found. So sudo apt-get upgrade. So update will get the list of updates, and upgrade will actually apply those changes. And so it will give us a list of a bunch of packages that it has found updates for. In my case, it has been 32 updates, and it'll download almost 24 megabytes, and it's asking us to continue yes or no. Press enter to yes, or to choose yes, just press enter. So we have all those updates installed. Now we can actually go about installing the web server. Okay, so like before, as an administrator, we want to install Apache 2, PHP 5, and then server and client for MySQL, which is a database. And we see there is a whole bunch of packages that will be installed. And again, we are asked to confirm and press enter. Okay, so it's going to ask you to create a password for the MySQL root user. MySQL, again, is the database program, which I will not be showing how to use in this particular video, but I plan to in future videos. And when you connect to MySQL, you use a username and password. And the root user is the administrator. It's the one that has all the power. So give it a reasonably secure password. Again, for this demo, I'm just going to choose a password of password, but pick something a little better than that. And type it in again. And then the rest of the packages will continue to install. Alright, so we've finished installing the web server and related packages. Let's verify that it is actually running. So on the, not on the Raspberry Pi, not here, but on your actual normal computer, go back to your web browser and type in the IP address of your Raspberry Pi. So again, mine happens to be 192.168.1.221, but yours will probably be different, so don't just blindly type that in. Make sure you use the correct one. Anyway, and so you can see here, yay, it works. This is the default page, and then there is some kind of basic guides right here that explain things. Okay, but that's great. Now we want to put our web pages here. Now, I mean, you could do it all through the command line, but that'll get really annoying really quick. There's a program called Swish, S-W-I-S-H, and it'll, okay, Swish SFTP, and then it will let you kind of see your Raspberry Pi hard drive from within Windows. And so we'll download it, click download. and open the file. And accept. And finish. So now if we go to File Explorer and go to this PC, we see there is a Swish device or drive in this area. Double click on it, and up here click Add SFTP Connection. We'll give it a label. I'm going to call it Web Server. The host would be the IP address of your Raspberry Pi. Again, type in the one for your Raspberry Pi, not just what I typed in. Username is going to be Pi, and the path will be /home/Pi, which is it's the home directory of a user in Linux, which is kind of like where documents would be. Click Create, and so we have a option here, and if you double click on it, the first time you connect, it will tell you that it has identified itself with a host key that it has not seen before, and so you want to tell it that you trust that key to store it, and go ahead and connect. And then we'll ask for the password, which is the password for the user Pi. So again, in this demo, my password was password, but type in your password. And then we see that the folder is empty. And if we go up, okay, check for updates, fine. Let's see, is the folder empty? Oh, it is. Okay, good. For a second, I thought we had a problem. Okay, so ls is the Linux equivalent of dir for DOS, which will list all the files in a directory, and there's nothing there. What we need to do is we need to create a link in that home directory to where the web pages are stored. And they happen to be stored in var www HTML, and that index.html is this. So we want to replace this eventually. So what we want to do is, well, first of all, let's make it so that the user Pi has full read and write access to that directory, which means you don't need to log in as an administrator when you want to copy over files. And you can do chown, which is change owner. The new owner is the username Pi, and then the path. And, you need to do sudo first, because you need to be an administrator to change owners. And in case you're not aware, I'm using the up arrow key to bring up the previous command. You can use up and down to look through your history. And now we'll do a similar command, but chgrp is change group, which is another part of Linux permissions. Okay, so now the user Pi has control over that directory, and we're going to create a link to that directory in the user's home directory. So ln-s, which is make a link, and s is for symbolic, which is the type of link, which is the kind you're probably thinking of. It's just a regular link. And then the source, which is var www.html, and then the destination, which will be home Pi, and yeah, we'll call it HTML. All right, so now if we go back to Windows, if we refresh, we see we have that folder. So, and this is the web page that we saw in Chrome. Now let's go ahead and delete that. And if we go back to Chrome, if we refresh the page, you'll see everything's gone because, well, everything's gone. If you just want a web server that'll host, random files, you can drag and drop them over. So if we go back to the web browser and we refresh, we'll see we now have that file. And if you click on it, it will load the file. In case you're wondering, this is just a photo of the inside of a calculator, a old version of the TI-83 Plus. But anyway, that's irrelevant. Okay, we could delete that, and let's create a really simple web page. So on your desktop, right-click, go to New Text Document, and we'll call it index.html. And I wonder if I think in Windows we need to show the file extensions, because I think that's index.html and there's a hidden .txt. I believe, yeah. Okay, so if you go to your File Explorer, go to Organize, go to Change Folder and Search Options, go to View, and then uncheck Hide Extensions. Yeah, so that's the problem that I was hinting at. There's the .txt, we need to remove that. So we're going to go ahead and rename, and click Yes. Okay, so that's what we need, because Apache is going to look for a index.html file. It is not going to look for an index.html.txt. Anyway, so now we have an empty text file, and we want to open it with Notepad. So right-click, Open With, choose another app, and More Apps, Notepad, and check Always Use the App. Okay, so I'll make a really simple, really crude web page. Okay, so really simple. Again, we're just going to show a string of text in the web browser. Hello from my Raspberry Pi. File, save, and go ahead and drag it over. Alright, so now if we go back to our web browser and we refresh. Great, so we have confirmed that we do have a web server, it's running, and it's serving what we want it to serve. Okay, but right now you can only access your web server from within your own personal network. It is not accessible on the internet. There's a couple things we need to do now so that people on the internet can see your Raspberry Pi. The first thing we should do is tell our router that if it ever receives a request for a web page, that it should pass it on to the Raspberry Pi. And you do that with I guess, technology called port forwarding. And I'll go ahead and log back into my router. Alright, so again, this part will vary depending on which model of router you have. So you'll need to do some research if you have a different model. Just search for your model number and then port forwarding. So on my particular router, if you go to WAN, W-A-N, which is Wide Area Network, and you go to Virtual Server, port forwarding, so it'll kind of explain it in this paragraph. What you do is enable port forwarding needs to be yes, and then down here we set it up. So a service name can be whatever you want to call it. I'm going to call it web server. And port range will be 80. Well, okay, it's not showing. Normally, there's HTTP : // HTTP is by default port 80. So that's why it's port 80. And then your local IP will be the Raspberry Pi, which would be, for me, 192.168.1.221. Again, that'll be different for you, so pick the correct IP. And the local port will also be port 80. And the protocol is TCP. And then you click Add. Alright, so just to reiterate, we give it a name. This doesn't really even matter. You can call it whatever you want. On the internet, if somebody makes a request to port 80 using the TCP protocol, our router is going to connect that request to the Raspberry Pi on its port 80. And of course, that'll be with the TCP protocol. So click Apply. Okay, great. So right now, if somebody wanted to access my server, they would need to know my IP address, which would not be this one, but it would be my public IP address. And there's a couple of problems with that. One is it'd be a lot more convenient if you had a .com or .org or .net or whatever, your own domain name. And two, the majority of residential connections, residential internet connections, have a dynamic IP. And what that means is your IP address changes over time. Usually it's not very often, maybe once a week, once a month, but it can change. So what we need to do is, why did Chrome close? Okay, that's weird, but whatever. If you don't have a domain name, you can buy one, and I'll show you how to do that. So domains.google.com. So there's many, they call them registrars, but there's many registrars, and one of them is domains.google.com. And they charge about $12 a year, and it's really simple and straightforward. It's Google. They keep things, fairly easy to understand. And I'll log into my account and show you how that works. So if you don't have a domain, you could go here and then you just follow the steps and you can buy your own .com. But I already have them, a few of them. So I'm going to go to Manage My Domains. And I'll go ahead and log in. So after you buy a domain, it'll be listed here. And what you can do is, for the domain that you want to set it up with, which for this demo is going to be cgartwork.com. If you go over to DNS and click on that, and make sure that you're using Google's domain name servers. Scroll down to Synthetic Records, choose Dynamic DNS, and www for the www.cgartwork.com, and then you click Add. And then hidden here, you need to click this arrow, and I'll go to View Credentials. So before anyone mentions, yes, I know I just showed you the username and password for that particular DNS configuration thing, but before I even edit this video, I'm going to reset that. If you click Need Help Setting This Up, I'm going to open that up in a new tab. So they explain it all here, and it's good to read through it, but basically they show you how to do it with the DD client and this one that I've never heard of before. I've used DD client before, but I've had issues with it, and to be honest, it might have been my fault. I don't know, but I'd rather just do something more simple. And if you go down to here, click on using the API. The easiest thing you can do is if you access this web page from anywhere on your home network. In this case, I'll have the Raspberry Pi access that. Google will know that this is your current IP address, and it will update its records. And so you replace username and password with the credentials that are right here. And you replace subdomain.yourdomain.com with your domain. So in my example, that'll be www.cgartwork.com. But again, that'll be different for you. So if you try to use that, you'll get an error. So keep that in mind. Whatever domain name you buy, that's the one you put here, www.whateveryourdomain.com. And then they list here the and by IP equals, but you don't need to put that. That's optional. They also tell you down here it's optional. Anyway, so what we can do is we'll go back to the Raspberry Pi. I'm going to go ahead and create a script, which is really just one line, but it'll be a shell script that will query that web page. So nano, which is a very small basic text editor for Linux, and then the file name, I guess I could call it DNS update script. .sh. .sh is the extension for a shell script. Press enter. Alright, so we're now in our text editor, and we can create this file and then save it. And a program in Linux for downloading a file is wget. And we're not actually downloading much of anything from them, but they will respond with, I don't know, 10 or 20 characters to let you know if it succeeded or not. So you're basically doing a download. And then let's copy and paste this so that we don't have to type it all in. So I copied that. If we go back to Terraterm, there is a neat little shortcut. Don't do Control V. It isn't going to work. It'll do that. It'll go down one line. If you right click with your mouse, it will paste. And it's kind of gone off the screen. Let's make that a bit wider. Okay, there we go. So now we need to edit this line. We need to replace username with the username, which will be this one, and copy that. Right click to paste. And change the password. Copy that. Right click to paste. And then change this last part. So again, for this demo, it's www.cgartwork.com, but that isn't going to work for you, so make sure you put in your domain name. Alright, so that'll attempt to download that file. What we want to do is we want to save that to a text file. And there's an option, which is do a hyphen and a capital O. Not 0, but a capital O for output. And then we can tell it what file we want to save that as. I'm going to call it DNS update results. .txt. And then we'll create, actually it'll be a 2-line script. The last line, I'm going to append the current date and time to that file. And I'll show you why at the end, don't worry. Okay, so that's the entire script. Let me review what we're doing again. So we're calling the wget command, which will let you download a file from the internet. In this case, the file is really just a web page. The web page's address is this long string of text, and the first part is the username, and then we have a colon, and the password, and then at domains.google.com/nick/update host name equals, and then your domain. So make sure you put your domain, not this one. All right, and then dash capital O, not 0, but capital O for output. We specify where we want that file to be saved to. So I'm choosing the name dnsupdateresults.txt. You can call it whatever you want. After it executes that command, the echo command down here is going to append a line of text to the end of that file. And it'll say last run, and then date is a program in Linux, and it'll print out the current date and time. These weird looking quotes right here, those are not single quotes. They are, I think they're called a backtick. It's the key to the left of the 1 on your keyboard. So if you look at the number 1 and you go to the left, or if you look at your tab key, go up 1, it'll be that weird kind of diagonal quote. I think it's an accent in some languages. But anyway, that's what Linux uses to say, execute this command, but then in place of date, run date, and then whatever it does, put it here. And I'll show you what this does. So we want to save the file, and if we look down here, it'll say Control O. That symbol means control, so Control O for write out. So Control O, and it will say file name to write, and that's what we want. So press enter, and we can exit. It'll tell you down here Control X for exit. So Control X. All right. So if we list the contents of the directory again with ls, we have that link to our web page directory, and then we have our script. Now I'm going to go ahead and run the script right now so we can see what it does. If you do ./DNS, and, almost forgot. Because it's a script, it's basically an executable file, and you need to adjust the file permissions to make that file executable. So chmod is change, I think change mode. Yeah, probably change mode. Plus X is add executable permissions, and then the file name. Press enter, and now we can do ./DNS. I'm pressing tab, by the way. Tab will autocomplete a file name. All right, so it did that, and then we see here that it hopefully saved it to our text file. You can use the program cat, which is short for concatenate, a really interesting name, but it'll basically show you the contents of that file. So cat DNS update results.txt. Press enter. We can see here Google responded with good, and then my public IP address. And then this is the part, that second line, last run, and then this is what date printed out, and it printed it in the file. So basically, we have our status here, whether or not updating our DNS record succeeded or failed, and then we have the date and time here, so that we can, if we look at this file, we know, hey, was this run like an hour ago, a year ago, what happened? And again, this will be visible in Windows. So if we go back to Swish and to the web server, we have it here. So if you ever want to look and make sure that you're updating Google, this is how you do it. Okay, but we want to execute this script periodically because your IP address can change. It'd be a good idea to run this script once an hour. Your IP is probably not going to change nearly that fast, but once an hour is probably a good option. It isn't too frequent that you're going to be annoying Google, and it'll still update your records pretty quickly if your IP changes. In Linux, there is a cron tab, which is a chronological it's a program that'll run things on a chronological basis. So if you type in cron tab -e, which is edit, the first time you run this program, it will ask you to pick a text editor. And I want to use now because it's simple. And so right here we have 2 bin nano. So type in the number 2. Press enter. Okay, so we have this text file. This is going to configure the cron tab. And you can go ahead and read these paragraphs, but I'm going to go ahead and scroll down and get right to it. So how it works, well, here, I'll just go ahead and do it first. Okay, so first of all, you're probably wondering what these mean, and they kind of hint at it over here. Come on. I think my computer's freaking out because I have it running in a VM and my computer is getting kind of hot with the screen recording software and everything. Anyway, okay, so the first value is the minute, and what I want is I want to run this at the start of every hour. So basically on the 0th minute, on the first minute, and then H is for hour. So on the 0th minute of any hour, any day of month, DOM is day of month, any month, any day of week. Did I put too many? I think, let's see, minute, hour, day of month, month, day of week. Yeah, okay, so I have an extra star. Okay, there we go. 0 minute of any hour, of any day of the month, of any month, of any day of the week. And then the command is our script file, home pi DNS update script. So basically at like at 12 o'clock, or 1 o'clock, or 2 o'clock, every time your minute is at 0 for any hour, it'll run that script. Anyway, so again, we control 0 to write that file. Press enter, and then control X to exit the text editor. And you'll see here that it installed the new cron tab. So right now it's 1:54, and in about 6 minutes it should run that program. And if we check the contents of this file, it'll probably say something like no update, or whatever the abbreviation for that is. And then it should say here, it should say 020000. And if you're curious about what all of the possible responses are, they're down here. So we had good. Oh, this is what I meant earlier. So no CHG, no change. We'll probably see that when it runs in about 5 minutes, because my IP is probably not going to change in the time. And then there's always possible errors. But yeah, generally you're going to see either good or no change. All right, so in theory everything works now, and we'll give it a shot. I don't know how quickly because I just created this dynamic DNS option. I don't know how quickly that's going to work, but let's go ahead and give it a shot. So I'm going to create a new tab, and if you remember correctly, my domain name for this demo is cgartwork.com. And let's see if it works. Error name not resolved. Okay, so yeah, the DNS system has not been updated quite yet. It'll probably take a little while. I'm going to go ahead and pause this video, and maybe in about half an hour or an hour I'll try it again, and I'll show you what happens. Okay, well actually just right after I paused this video, it worked. So I'll create a new tab, and we'll go there again. And there you can see, it works. And this will work from anywhere on the internet. Come on, why does Chrome keep crashing? That's really annoying. Okay, so that'll work from anywhere on the internet, not just on my home network. www.cgrarc.com, and that is actually in real life serving it from my Raspberry Pi. And so basically that's all this video is. I hope you enjoyed it. To summarize, we got a Raspberry Pi, we prepared an SD card, we set up Raspbian on it. After we set up Raspbian, we went ahead and downloaded all of the updates. After that, we installed Apache, PHP, and MySQL. After that, we set up Swish in Windows so that we can access the Raspberry Pi's hard drive from within Windows. And then I showed you how to, well, I kind of hinted at how to buy a .com through Google domains. And I showed you how to set up one that I'd already bought with a dynamic DNS service that Google provides at no additional charge. And that's really all there is to it. It's very simple. I know it's kind of a long video, but I was trying to explain things as I went. I hope you enjoyed the video. If you have any questions or comments, please leave them down below. If you like the video, please share it with anybody that might benefit from it. If I have time, I've been kind of short on time recently, but if I have time, I plan to do a bunch more videos on how to have an Arduino talk to the Raspberry Pi, and also how to set up a VPN server with the Raspberry Pi, which can be a really helpful tool if you ever have to travel. That's the end of the video. I hope you enjoyed it.
For beginners, lesson 1. Today we're going to talk about variables. You're going to learn about what they are, how to declare them in Swift code, and furthermore, how to use them. Alright, so let's get started. For the rest of the lessons in this series, we're going to be working inside this app called Xcode. Xcode is the tool that Apple has provided for people to build apps with. And inside Xcode, you're going to be able to create your user interfaces. You're going to be able to write the code. Hello, welcome to Learn Swift Programming for Beginners, Lesson 1. Today we're going to talk about variables. You're going to learn about what they are, how to declare them in Swift code, and furthermore, how to use them. Alright, so let's get started. For the rest of the lessons in this series, we're going to be working inside this app called Xcode. Xcode is the tool that Apple has provided for people to build apps with. And inside Xcode, you're going to be able to create your user interfaces. You're going to be able to write the code to express the logic in your app. You're going to be able to test your app even. So that's why this is where we're going to start in learning Swift. We're going to be writing the Swift code inside the app that you're actually going to run Xcode, or you might have to use an alternative solution to build iOS apps. So check in the description below for PC solutions. However, if you are a PC user, don't let that discourage you. For me personally, I lost about 2 to 3 years of learning iOS development simply because I didn't have a Mac and I didn't want to get a Mac. But these days there are alternative solutions. You don't actually have to buy a Mac computer, although I eventually did, and now I haven't looked back. So anyways, now that you have Xcode and after you've installed it, it's a pretty large install. It's a pretty big program, so it might take some time, but after you have it installed and you launch it, you're going to see